Good evening, everyone, and welcome to Sky Observers Hangout. My name is Michelle. We're so happy to see all of you today. Actually, we can't see you, but you can see us.
I'm sure we're familiar faces at this point if you've come to Sky Observers Hangout before. My name is Hunter, a public observing educator here at the Adler. Joining Michelle here for this fantastic live stream, doing a little bit of gazing at galaxies today. Very, very exciting. So we've got some other friends helping us behind the scenes today. You'll see that Jennifer is there helping us in the chat as our chat moderator. Hi, Jennifer. Thank you very much. If you see the Adler's name highlighted in yellow, that's going to be her giving you lots of useful links that you can follow, helping pass your questions along to us. So that's a really important thing that I want to bring up for today is ask away. Any questions that you have about the stuff that we're looking at, we are here with answers for you. So make sure that you are leaving those in the chat. I know Jennifer also said, mentioned in the chat, maybe drop in where you're joining us from today. So that's another thing that you can mention there. We would love to see it. So tell us a little bit about Sky Observers Hangout, what we're going to be doing tonight, Michelle.
Well, Sky Observers Hangout is our place and your place to gather together to nerd out about the sky. And so if you want to interact with us, we love that. Just as Hunter said, please put your questions in the chat and please put where you're joining us from. But if you don't want to do that, that is perfectly fine. It is just fine to sit back and watch. But tonight we're going to talk a bit about galaxies. Now, we are here in a very special place. You may not recognize this room that we're in. We're here in the Doane Observatory at the Adler Planetarium. By the way, we're open for visits, not necessarily this very second, but we are definitely open. Jennifer's going to put a link in the chat where you can, if you want to come visit us, you can buy tickets to be able to do that. You can learn all about us if you don't know about the Adler. So yeah, tonight, galaxies. It's kind of a tough thing to see from downtown Chicago.
You're right. Yeah. So this is actually like my first point that I thought about when we were talking about this today is like, this is kind of a different show than we usually do a little bit. A lot of the times we are focusing on like specific celestial events that are going on, right? Oh, that's true. Good one. Good one. Sorry. Camera jokes. Often focusing on like something specific, maybe an eclipse or a conjunction or something. Tonight is a little bit of a different show. Tonight we're focusing on, sort of a category of objects that you can observe in the night sky, taking advantage of the big telescope behind us here, right? So the Doane Observatory was mentioned. This is the 24-inch telescope that's housed inside it, taking advantage of that big mirror, gathering as much light as possible, and trying to take a look at some slightly deeper objects in the night sky, some further away things, right? So it's very exciting.
Do we want to see where some folks are joining us from? Oh, who do we have?
Yeah, I see a couple. We've got Chicago, lovely, wonderful. Hopefully you can come visit us in person, but also Montreal, exciting. So some Canadian visitors today. So understandably, you may not be buying tickets to the museum, but if you still want to stay connected with the Adler, subscribe to the YouTube channel. You'll be able to see future Sky Observers Hangouts, but also a ton of other awesome content that is getting made for our YouTube channel. So that's a good way to connect. Oh, and some more Canadian visitors, Toronto as well. How exciting.
You're a hit in Canada, apparently. So that's
great.
Awesome.
We love that.
2 places on my bucket list to travel to.
There you go. Toronto's really nice.
Hey, Toronto, Montreal, you come here. We'll come visit you sometime. We want to see your beautiful cities.
There you go.
It'll be a lot of fun. So yeah, keep it coming. Jennifer's letting us know where you're writing in from. So definitely keep letting us know. Now, yeah, you want to show them a telescope view? Do you want to show them?
Sure. We always love starting straight with the telescope view. So why don't we go ahead and switch over to that? Now, you might look at this and think, Hunter, Michelle, what the heck? That's clearly not a galaxy.
Not a galaxy.
So, Michelle, let's talk about why we're starting with this object today. Talk a little bit about what we're looking at.
Yeah. So it is 9 p.m. Central Time, or just after 9 p.m. Central Time here in Chicago. You may notice we are kind of bundled up. It's chilly out tonight.
Got my hot hands at the ready, hand warmers ready to go.
I actually have 4 of them in my pockets right now. So anyway, But we're waiting for it to get slightly darker. And so we thought, oh, we might as well show you something we can see with the big telescope right now. So this telescope here in the observatory is a 24-inch wide telescope. And so that means the main mirror is 24 inches across. Basically, it takes your little tiny eyeball and turns it into a 24-inch wide eyeball. And not only that, we've got a camera on the back of the telescope. And so that allows us to point at stuff and show you a live view. This really is a live view. We've got it tracking this object right here, which is called a globular cluster, specifically M13, the 13th fuzzy thing that Charles Messier cataloged a couple hundred years ago or so.
You'll get very used to that catalog this evening. Tons of Messier objects.
Yes.
Today.
So M13 is this one, also called the Hercules cluster. But this is a cluster of very old stars. The stars in this cluster that you're looking at right here, the stars themselves are 10, 11 billion years old, 12 billion years old. That's billion with a B. So quite old. But these stars were around at the beginning stages of our Milky Way galaxy. And so they orbit, this group orbits around the middle of our Milky Way galaxy. So we wanted to show you something that is common for galaxies, we think. So we think galaxies contain these, or they orbit galaxies like ours. And
right.
so
sort of a feature that you get in galaxies, right? So while we aren't looking at an entire galaxy in itself just yet, this is a sort of an additional feature in a galaxy that's maybe a little bit separate from the traditional stars, like within the spiral of arms of the Milky Way, like we are, and looking out to these sort of outer areas of the Milky Way.
Yeah. And what's also interesting is you go, wow, that's a lot of stars. That's not even the half of it. There are
compared to what's there.
Hundreds of thousands of stars in this group. It's that this is the amount that we can see with the camera settings that we've got right now. I don't know if they can see the camera that we've got on the.
Move my head out of the way.
There you go. So yeah, it's right there.
The little red thing.
Yep. And we've got the camera set. I think they can see our settings there on the side.
Yeah.
So the settings there on the side indicate that we're taking a 10-second exposure. So every 10 seconds, we're getting a new exposure from the camera. It's also insanely windy out right now.
Yeah.
I don't think you can hear it in the background, but we definitely can. But it's
we can feel it too a little bit.
Yeah, but it's affecting the visibility of anything we're going to look at tonight, because everything is going to jiggle around kind of a little bit, and it's going to make everything a little bit fuzzier than we really want it to be, but it's okay. It's clear out. We'll take it.
Right. At least we don't have any clouds tonight. So but it's definitely a good thing to keep in mind. So a lot of these objects that we're pointing at today while we're thinking about galaxies are things that are very distant, very dim objects, really pretty small in terms of how much space they're taking up in the sky. And so those kinds of that atmospheric turbulence will definitely affect things. So it's not perfect seeing, but at least we are seeing. Exactly. That's definitely a plus. That's definitely a plus.
Windy and jiggly stuff over and clear over cloudy any day.
Absolutely.
It's okay. So do we have a few more folks? Oh,
yeah, I see. Again, more Canadian visitors. Hamilton, Ontario.
Yes.
Yeah.
So we've got Hamilton, Ontario, Toronto, Montreal. My goodness.
Yeah, everybody who's joining from Canada today, it's like, where's the west coast of Canada in our representation? We just got the eastern half of the country.
Hey, BC.
Let them know. Yeah, they need to start joining too.
Right to your friends and let them know to tune in. Anyway, so yeah, we've got our live view right now of the Hercules cluster, which, looks actually to me kind of spectacular. Should we move the telescope? Do you want me to move the telescope?
I think we can try it out, at least give it a shot. Maybe we could set some live stacking to try and build up an image over time. So you might learn like some of these terms that we use in astrophotography a lot today, right? So these things that we're imaging are very dim. This is already, a lot more stars than you would see if you were looking at this directly in the eyepiece, right? So it's very different from looking through a telescope, even a big one like this. It's gathering light over this extended period of time, right? This 10-second exposure.
The cool thing is, though, if you do look at this object through our telescope, it does look like this.
Oh, it's still awesome. Yeah.
You just wouldn't see this many stars.
Exactly.
So we're gathering more light than your eyes would normally see. So we're about to move the telescope to go to another Messier object, an M object, M101. But before we do that, we're going to talk a tiny bit about galaxies. So going to give you just a little sense of the types, the couple types that we want to point our telescope at tonight. And fingers crossed, knock on wood, well, knock on plastic. Then hopefully we'll be able to show you what we want to show you. So
right. So the plan for tonight is to look at a couple of different galaxies that really exemplify the main kinds of types of galaxies that are out there in the universe.
Yep.
So we have this image here. I'm sorry, we are kind of in the way. If we need to maybe see some of the top corner, I'll move us. But so this is the Edwin Hubble's classification scheme. You might be familiar with the name Hubble, right? His name was used for the Hubble Space Telescope.
Yeah.
He was alive a little longer ago than that.
Yeah.
But he was the person that came up with this galaxy classification. So can you tell us a little bit about these different kinds of galaxies that we have out here?
There's a couple of main groups. I mean, there's definitely more than two main groups, but you can pretty much classify your galaxies in 2 or 3 or main groups. Spiral ones, pinwheel shaped ones. So those are the ones with the arms, all right? Mm-hmm. Round ones, or round-ish, or football shaped or oblong. Anyway, something round-like, and we call those elliptical. And so spiral and elliptical are the two main types where you'll see some kind of a shape, and then you'll see different kinds within those two main types of galaxies. There's also irregular.
Right. There's some that don't really fall quite into the classification scheme super well.
They don't really have a shape.
Just a small handful. Yeah. Nothing compared to the quantity of these kinds of shapes.
And then there's another type called lenticular. And think of lenticular as like a spiral on steroids, like spiral, but very dusty. And some of those spiral arms just they look sort of like they're merging together. It's just a really strange shape. But anyway,
I was going to say that when looking up the pictures for this classification scheme, I will say I chose the simpler one. I think this is more of the original classification scheme. Now, if you looked it up, they might branch off a few more different ways and things, right? Yep. As we continue to discover more and more galaxies out there. Okay, so we know what our main types of galaxies are.
Yep.
So I think we should start with we've got kind of these two options.
Yep.
I say we start with spiral galaxies. It's one that we are very familiar with, right? We are here in the Milky Way, a spiral galaxy of its own.
Yep.
Right, and they're also one that are very, very abundant in the night sky. Right, there's tons of spiral galaxies out there. So I think that that would be a good way to start is switching over to a spiral galaxy.
Why not?
Start working on that.
So I'm going to go over to the computer, which is right here. So the two screens are behind me here. This is what we use to control the telescope. I'm going to click and the telescope will move. I'm going to need to move the roof because we've got an opening in the roof and the opening has to point in the same direction as the telescope. And then I'm going to have to change the exposure time, but hopefully that's the only thing I need to change. I'm hoping we just change it to about a 20 or 30 second long exposure. See what we get. One
note that I will say is that because we are working with these very dim objects, something like a really bright ring light on you can certainly cause some problems with observing. So when we do switch over to the galaxy, we will probably be turning the ring light off and then maybe turning our camera view off as well. But hopefully you'll still be hearing us. And you're not here to look at us, right? You're here to look at through the telescope. Right? You're here for the galaxy.
So I'm going to go over here. Hunter's going to stall while I move the telescope. So you'll be able to see that.
Our first target that we're going to tonight, and it was so fortuitous that it worked out like this, is going to be the Pinwheel Galaxy. So this is a spiral galaxy. Its number in the Messier catalog is Messier 101. There goes the moving telescope.
Okay, I'm going to move the roof.
All right, we're moving a roof. I apologize if it is loud on the microphone. So I think you could probably have saw it spinning behind us there. Do you think I should turn the light off now, Michelle? Just to give it the best chance. All right. Sorry, we are going to go dark here. but I will keep our camera on for now since we don't have anything else that we are looking at yet. So what we are looking at right now is going to be Messier 101. And this one has been particularly in the news recently because it actually had one of its stars go supernova. So I think it was on maybe the 20th, maybe the 19th that it was first discovered. When looking at a galaxy, you will suddenly see this new very bright spot appear, right? So they can compare that to past days of observing, see how it changed. Notice that there's this new bright spot there, and that is a star going supernova. So it's really, really lucky that that happened just a few days before we planned on doing this live stream, which we have had planned as a Galaxy show for a really long time. So very, very exciting news. So glad that we can hopefully take a look at it tonight. Hopefully the wind won't be too much of a problem. You can see Michelle working away back there.
Yep.
Should I switch us over to the to a view of the computer? In a second. We're getting close. Oh, here we go. It's coming through. So I've switched us over here. Can see it's still working down in the bottom right corner of the screen.
Yeah, it's gonna switch. I changed one of the settings. So there's a setting called binning, and that basically helps us see dim stuff a little bit better. So I switched it in the middle of taking a frame. So that's why the frame went dark. So hold on with us.
It's okay. You can see a little green progress bar in the bottom right corner. So only a few more seconds until we get these exposures.
Yep.
Like we said, these are very dim objects. So you have to do extended exposure times. When doing astrophotography, you will take many long exposures and stack them together, amplifying that even more.
I think we got it.
I mean, it's the bright spot, like kind of right in the middle, right?
Right in the middle, yeah.
Is there any way to make that bigger on the screen?
Yes, it may cause it to be fuzzier, but
Yeah, that's okay. That's okay. It's so small right now. So a few features that I want to point out that we are starting to see here, and they are pretty dim, so it's good to point them out. So you'll see actually, yes, I would look. Can you point to the center of the galaxy first? Okay, so you can kind of see the spiral coming through there. You have the fuzzy point in the middle, which is the very center of the galaxy. But the very exciting part for today is, yes, what Michelle is pointing at now. That is the star that has gone supernova. So right, it should be. We don't have a great view of the galaxy right now. It'd help if we could see the actual spiral arms, because we know the place of it in the galaxy itself.
All right.
So I'm excited. This is the first time that we have looked at this as well. Sorry, I got a little bit lost in the screen for a second.
Yep. So one thing that we need to check is if the supernova is that bright spot there, or if it's the
could be one of the
spot off
other
to the
smaller
left.
bright spots.
However, a picture that one of our volunteers took a couple days ago.
Oh, this picture that we have on the slideshow is actually the image that was used in originally discovering the supernova. So this one is from Koichi Itagaki, a Japanese astronomer, and like supernova hunter, essentially. He is looking for these all the time, was the one that discovered this. So you can see it highlighted on here. And if we are able to get a little bit more definition in the pinwheel galaxy itself, then we would have an easier time like pointing out for sure that that's the supernova. Now, I will say this was a few days ago when he first discovered it. It was the 19th of May. And so you can see actually here, let me turn off our picture. Up in the top right of the image, that the supernova was only at about magnitude 14 then. So very dim at this point when he discovered it.
But that tells me we are pointed at the correct thing, because if you go back to the live view of us, or the the galaxy. Okay, so we've got the spot in the center, or the fuzzy thing kind of slightly above center. The spot over to the left of that is
that bright
star, or possibly that one. But no, it's that one right there. And then the supernova is the one at the bottom.
Yes. So when that picture was originally taken, it was only a magnitude 14, almost 15. So that's very, very dim.
All right, take that back. I'm checking. It may be the one off to the right.
This one off to the right?
Yeah, it may be the one off to the right. because it may be this right here. Sorry, I'm pointing at the screen. You can't tell what I'm pointing at. The two of us are investigating this. This is the first time we've actually been able to see it. It's been either cloudy or
Yeah, we've had pretty poor weather here
Yeah,
this week.
exactly.
So we've been trying to get out here for a few days, and this was our first
So,
chance.
I
And it should be
think-
up around magnitude 10 at this point, right? So we can
Yep.
see that the center of the galaxy is dimmer than that, right? Back when Koichi Itagaki took his picture, it was still much dimmer than the center of the galaxy, right?
Right.
But at this point, it should be matching it.
Or is it the one
Not
off to
shining
the
it.
left?
It's hard to know.
It's hard to know because we need to, it'll be flipped. And we're trying to figure out.
Unfortunate warning message that I see we just got from the telescope. Last
Oh.
5 frames have not been stacked. Could not align. I wonder why. Maybe it's because of the horrible wind that we're having. Yeah, that's unfortunate. So what live stacking is it will stack the different frames that you're having together and combine them to create one even brighter image, which would help because we would see more definition in some of those spiral arms in the galaxy itself, which would help us know, which direction, which way it is all aligned and facing.
All right. I've changed the exposure time again. I'm going a little bit
A little
longer.
Mhm.
So give us about 30 more seconds and it'll switch. Anyway, so
One thing I think would be great to talk about is we keep saying this word supernova. What's going on here, right? This
do you want
bright
to switch,
spot.
switch to Koichi's picture? There you
So
go.
let's talk about what even is a supernova, right?
Yeah.
We're seeing this new, what looks like a bright star appear in the sky,
Yep.
right? It's got this crazy name, SN 2023 IXF.
Yep.
What the heck does that mean? What is a supernova?
So this is a star, it was a very large star. It reached the end of its lifetime. It stopped creating energy in its middle. And when that happened, then you have all these layers of gas over the middle. You don't have any more energy pushing outward. You've got gravity pulling all that stuff inward. And then all of a sudden that stuff rebounds outward and explodes. And so this is basically the end result of the lifetime of a very large star, or what was a very large star. And so this will not happen to our sun. Our sun is not big enough to do this. But this is something that is pretty neat to see in other galaxies like this, especially because this galaxy isn't that far away in the grand scheme of things. However, one thing we have to remember is this galaxy is 21 million.
Not that far away in the grand scheme of things. I mean, think about the scales we're talking about here, right? We have our Earth, right?
Yep.
Inside the solar system, inside a single spiral arm of the Milky Way galaxy, which is just one of these, billions that we know are out here now.
Exactly.
And, this is just one of those that happens to be kind of in the local neighborhood, but still 21 million light years away.
21 million light years away. So that means this star exploded 21 million years ago, and the light from that explosion finally reached us.
Finally reaching us
a week ago.
Yep.
So what you saw in Koichi's picture is as the supernova was getting brighter. So the explosion, for lack of a better word, we'll call it explosion. It exploded, and then the material was running into other material that was around that star, and that's what causes the supernova to brighten probably till about today. And then after today, it's going to start decreasing in brightness. It could still be visible to big telescopes for a long while, weeks, maybe months.
Yeah. I think the estimate for the magnitude it had reached now was about 10, right?
Around 10,
around there, 10 or 11,
something like that.
So not particularly bright, but one of the closer supernovas that we've had in recent time, right? Due to the proximity of this galaxy to us here in the Milky Way.
Exactly.
Should we switch over to our live view of it here? Yeah.
So I'm still trying to figure out exactly which one it is. I know it's in the view. It's which one is it? We know that the supernova is outshining the center of the galaxy, which is kind of amazing.
Right. So think about that, right? The center of this galaxy, tons and tons of stars there in the middle, an entire galaxy, right? Built of billions of stars.
Yep.
And this single exploded star, right? This single supernova is powerful enough and releasing so much light that it is outshining the entire galaxy itself.
I'm wondering if
I'm trying to think about which way it is turned.
yeah.
So we still have the image pulled up from Koichi Itagaki.
Oh, I think it's the ones over to the left. I think it's the one over to the left. So we're what you can't see is we're pointing at the picture. And so we're trying to figure out if it's
which way it's oriented.
but
Right?
it's-
So telescopes flip and things a lot of the time.
So-
Exactly.
So I'm thinking it's flipped this way. And so that means it's the one over to the left and it's the one on the
Think
top.
it's
It's
that one?
It's that one.
You know what? Actually, that's such a good point. So thinking back to other galaxies that we have imaged out here and seen, they do
So-
typically take up the entire field of view of the camera. So I bet you're right. So we think, okay, Michelle's pointing it out now with the mouse. We were maybe underselling it a little bit before we thought it was one of the dimmer ones, but I think you're probably right that it is that bright
I
one.
think it's that one.
Mm-hmm.
So, because it,
That would make sense with I see what you mean, that this is the other bright spot there.
yeah. So this is.
And that would make sense because this would be that one, right?
Right. Except, so it's
It's
turning.
tough to orient yourself when you can't really see like the definition of the spiral galaxy there.
I think it's that one. Oh my goodness. Oh, this is crazy. And so, yeah, I'm going to actually increase the exposure time even a little.
A little bit longer. Okay. So to give you some reference, there are absolutely supernovae happening, all across the universe, with some kind of frequency, right? There's just a lot of stars out there. So the likelihood of something like this happening is, inevitable. But this one is particularly close to us. It's a galaxy that is not too far away from us here on Earth. And so that is what makes this one so exciting. It's much easier to see with a telescope than a lot of other ones are, right? Some that are in much, much more distant galaxies, right? This 21 million light years sounds insane, but in space terms, that's pretty nice and close.
Yeah. So I changed the exposure time to 60 seconds, and I also increased what's called gain. And gain is basically, you could call it changing the electronic brightness.
Mhm.
So we're not changing the brightness of the actual, or we're not changing the amount of light that the camera is bringing in. Once the camera has gathered the light, we're basically boosting the signal artificially.
Mhm.
So,
Wow. So you can already see that so many more, a lot of them being background stars
yeah.
are showing up now. So now we can try to piece together. So one thing that is difficult about this is that the image that we have is oriented differently than ours is. So different kinds of telescopes, depending on the lenses or the number of mirrors they use, will flip and reverse images in different ways. So without knowing, what kind of telescope Itagaki was using when taking this image, it's kind of just a case of exploring and
Yep.
trying to compare the different ones and flip it and reverse it in your head, which can be kind of confusing.
So I'm wondering. Huh.
If
we
that
could
was
see-
that, and that would make sense, right? Then it would just be flipped this way, and then it would be that point.
By the way, if you're wondering about that
Oh, and
donut,
look.
that donut,
The other little spot right near it. That's definitely the brightest point on the screen here would make the most sense to me. Because you can see these two, which are these two, right? And these two right here are these two. So that makes sense. It's just flipped this way.
that way.
Mhm.
Okay. So the supernova is,
Is the
the bright
brightest
one.
point there, yeah.
okay. I'm going to actually increase the brightness even a little more. We're
Little more.
starting to get a little bit more definition. A
And
tiny
you
bit more
can see a
definition.
little bit of the actual spiral arms of the galaxy itself coming through a little bit now. So you can see near, especially if you focus like near the supernova, that's a point that we can focus on. And then look at the background star that's just below it and to the left. You can kind of see a little bit of that dustiness there. It's in one of the outer spiral arms of the galaxy here.
And
You can see a little bit of that there.
yeah, exactly. Oh, that's right. Yeah.
Mhm.
So I was going to say something and now I completely forgot what I was going to say. So I'm going to go change the exposure time slightly. Oh, I remember what I was going to say.
She's remembered it, folks. Very exciting news.
All right. If
Okay,
you're wondering what that donut looking thing was over on the left, that is a dust spot somewhere in either the telescope or on the camera. So when we take images to try to process them, basically we try to process out some of those dust spots and things. So that donut, we can't do anything about it in this version of the imagery or anything. But if we take some pictures later tonight of this galaxy, which we're planning on doing, then we can process out
in
that
processing.
you can get rid of that donut. So got another maybe about 30 seconds or so.
Yeah, we can see the little progress bar in the bottom right corner.
I mean, the fact that we're showing you any galaxy from downtown Chicago is remarkable. That's why we're kind of geeking out doing this.
I mean, the supernova is pretty darn exciting too. I mean, it was just such wonderful timing that it just happened, over the weekend. Sorry, slight roof adjustment. Okay, so there we got the extended exposure there, and you can see that at this point, like the supernova is actually almost too bright. It's kind of blasting out a lot of the other stuff.
But this may help us determine for sure which object. Yeah, I think this
is a pretty distinct shape over here.
Yeah,
this Y shape,
and that's this right here.
It should be right over
and
there.
it's flipped.
Yeah, exactly.
Yep. Wow, that's cool. All right.
It is really
so
cool.
The bright one is the supernova.
And yes, I really like that you can make out some of that, some of the spiral arm there of the pinwheel all the way out by where the supernova is. But it's kind of right all the way out there. So it's really out in the, if I switch back to this picture, you can see that it's way out in the, that it's way out in the very edge of one of those spiral arms in the galaxy, right? It's not close to that central core of M101. And so if we then return back to this view here, you can almost see some of that you can see some of the little dust arm there in between the supernova and that other background star next to it. Oof, you can tell that there was a big gust of wind during that last exposure. Look at how blurred the image is. It's really tough to pick up a lot of the smaller details and things on the galaxy when we are battling this wind a lot.
Yeah, exactly.
So we were lucky on some of those shorter exposures that it worked out a little bit better. But here you can really see the effects, the kind of stretching of all of these different stars and the supernova in particular.
And the core of the galaxy, that fuzzy splotch there, a little bit above the middle of the picture, that is always going to be the brightest area of a galaxy.
Absolutely.
The spiral arms are going to be a lot dimmer.
Much dimmer.
That's why when you see pictures, Hubble pictures, any professional picture, it's going to be hard to pick out those spiral arms because the middle is going to be a lot brighter than the rest of it. So a lot of times these pictures are going to be lots of individual images stacked together. So we can kind of get rid of some of the noise in the background. But tonight we're just literally showing you one picture at a time, one picture every 70 something seconds.
Absolutely, yeah. And we do have some other pictures that we've taken here in the Doane, looking at some galaxies. Yeah, there's the new fresh exposure. You can tell the wind definitely picked up. We've got some pretty bad gusts happening right now.
Yep.
But maybe the lesser views are a good segue into, one thing we always like to talk about here, right, is not only do we want to show you views through the big telescope, but we also want to be able to encourage folks like the folks joining from Ontario and Quebec and things today, encourage you to go outside, do some observing of your own. And so we had some things that we wanted to talk about some galaxy observations that you can do maybe in your backyard, depending on where you live, maybe, an hour or two drive away if you live in a big city like we do here in Chicago. So here, I'll advance a little bit on these slides here.
Yeah.
So, of course, talking about spiral galaxies here in particular is a great segue into our home here in the Milky Way, right? So, being another spiral galaxy itself, and this is definitely going to be the easiest galaxy for folks to go out and observe, right? This is one that we're inside it, so of course it's going to be the easiest to see. Now, you're not going to be able to see the entirety of the galaxy at once, right? Again, because we are inside of it. But the great part about this is it doesn't require any equipment. So what are some tips that you have for folks trying to get a view of the Milky Way like this across the sky?
So my several tips are, number one, get out where it's dark. You need to be out where it's dark. Light pollution of just about any amount is going to keep you from seeing it. So definitely need a dark sky. Number two, go out when the moon is not bright. So maybe a crescent phase is fine, but anything more than that is going to start to wash out the view of the sky. So you want to go around new moon if you can do it.
I think that's a tip that a lot of people don't think about sometimes if they're new to observing, is that the moon really is so bright, it's so reflective that it really does greatly affect your ability to see dimmer objects in the night sky.
The moon is a source of, you could say, light pollution. At least it's the source of light.
Yeah, there you go.
It is not light pollution, but it is a source of light that you have to contend with. And number three, go out in either the summer or the winter. So the summer time sky and the winter time sky means in the early evening, getting into the middle of the night, the Milky Way is going to be high overhead, or at least higher up in the sky. Your latitude will make a difference on that. But still, those are two of the best times to go out. Springtime, fall, not so much. The Milky Way will be more near to the horizon. So it'll be a lot harder to see. So summer and winter, go out when the moon isn't bright, and get out away from city lights. And then what you want to look for is what looks like cloudiness across the sky. You want to go out when it's clear, but you're going to go, wait, it's not actually cloudy. The cloudiness is distant stars kind of all fuzzing together. And so, that's basically it. You don't need a telescope or binoculars.
This picture is really, if you're in a really dark sky, that's not a bad representation of what it can look like.
Absolutely.
If you allow your eyes to get dark adjusted, right? Spend a good amount of time outside, put your phone away so that you don't have that light affecting your night vision, right? Let yourself really appreciate the sky. As you are looking up, you will continue to see more and more details come into view. Your eyes will, your pupils will open up a little bit more. You'll have I made a video about it. Rhodopsin start to build up in your eyes. I think that's the name of the chemical that builds up. It will start to build up in there, right? And you will begin to see these dimmer objects, and then the Milky Way will really come into view.
Yeah.
So this is a great one. If you can get out to a dark sky, this is definitely the number one way that you can do some galaxy observations of your own.
Yep. You're going to need to give your eyes at least 20 to 30 minutes to adjust to the dark. And if you turn your phone screen on, give yourself another 20 to 30 minutes.
It takes like 1 second to make all the rhodopsin go away. I remember that from making the video too. So.
All right.
And, I think one thing that I had here was, we have mapped out and created these sort of artist concepts of what the Milky Way would look like by using these locations of different stars that we've seen out here. So the first one that we were looking at was a regular spiral galaxy. Our best idea right now for the Milky Way is that it's a bit of a barred spiral, right? So you can see that kind of bar in the middle, the line across the center there. Yeah,
right there.
Michelle. Before it hits the spiral. So it's a slightly different kind of category of things. Now, if we show where we are in the Milky Way, I think this does a really good job of explaining why certain seasons are best, what you're going to be seeing, right? So we are in this part of one of these spiral arms here in the Milky Way, right? And it is, I guess a good way to describe it is it's a very flat disk, right? It's kind of like a big plate, right? It's not a sphere of stars, these spiral galaxies.
Correct.
That is a big feature of them. So in the summertime, if I'm not wrong, you are pointing more towards the center of the Milky Way, right?
Correct.
So during the summertime, that's when you'll see kind of the dustiest sort of cloud across the night sky. In the wintertime, you're pointed out towards the other spiral arms. So you'll still get great views of the Milky Way, but maybe not quite as bright of a streak across the sky. So if it's your first time, maybe the summertime, it would be easier to recognize it. Now, spring and fall, we're just not facing either of those directions, right? I guess if you imagine you're facing out of the screen or into the screen, right? And
You're
so
facing to the side.
to
Yeah,
the side,
to the side. Yep. So the view is just not great in the spring and fall. Just don't have a good view of the Milky Way. So yeah, summer and winter, best times. Summer because it's warm out, but winter can give you some nice crisp skies as well.
Mhm.
Are we going to show them going to try to show another galaxy?
I think we should give it a shot. So we've
Right.
talked lots about spiral galaxies so far.
Can we try for
I don't
M87?
want to forget about an elliptical galaxy. Yeah, I think we should try for that one. So we're going to give it a shot with one more galaxy tonight. See how it goes. It looks like the wind, or it feels like the wind has calmed down a little bit from our previous images that we were taking. So we'll try one other galaxy tonight to really exemplify some of those different types that you can see in the sky, right? So this next one that we're going to show is a much more clear example of those elliptical galaxies, the ones that were, I guess here I can take us back to that slide here for a second. These more spherical galaxies here, right, that do not have these clear defined arms. Okay, moving the roof.
Okay.
Apologies again for our camera view being so dark, but I really want to make sure we have the best chance of getting some decent observation as we can. Was it that fast?
Is that bad?
Wow, that's pretty good.
So cool.
It's nice having a big telescope, right?
Geeking out.
The galaxies are fun. What can I say? The galaxies are fun. So this one that we're looking at is, correct me if I'm wrong, M87, right? That's the number?
Yep.
Okay, sorry, I have trouble remembering the numbers sometimes. So this one is called M87. Wow, that looks great. All right, so I think we can all probably tell which point is the galaxy in this, right? So you can see like bright individual spots, but the fuzzy one in the top center is the galaxy that we are going for tonight.
I just changed the exposure a little bit.
Yeah, it looks really nice right now. Now I'm wondering, okay, so one feature, right? So with spiral galaxies, right? Everybody's looking for these big arms,
Yep.
right? They have these very interesting shapes.
Yep.
These elliptical galaxies are very different.
Correct.
They're very spherical, you
Yep.
know, kind of one single point of light, gradually getting dimmer outwards.
And yeah, the M87 galaxy specifically has more of a football shape, I guess you could say. It's not completely round. It looks round, but they're not all completely like you would think of a sphere of stars. Think of more like a football of stars. Sorry, American football or Canadian football, either one. So yeah, the ball is basically the same shape, but not soccer ball round. So anyway,
I actually just thought of soccer ball because I saw that somebody was also joining from Mexico City checking in today. So
Hey.
Canada, USA, and Mexico reminded me of the next World Cup coming up.
right. This is so amazing.
Wow.
Oh my gosh, M87 looks so good. Oh gosh, I'm sorry, geeking out some more.
So one thing that's really interesting about M87, and one thing that is like really cool about these galaxies and a lot of these elliptical galaxies, is that they are very, very, very massive, right? They have tons and tons of stars inside of them. They also have tons of globular clusters,
Yep.
something that we looked at earlier, right? So, you know, the Milky Way has about 150 to 200 clusters surrounding it. M87 has in the thousands, right? It's a really big difference compared to what we have here in the Milky Way, right? I think the closest estimate is about 10,000 for the amount of globular clusters that have been counted around M87 here, this galaxy. It's really massive. It's got tons and tons of stars in it. I was wondering, let me see how far away this one is. I have my little spreadsheet here of all of our different potential galaxy targets for the night.
We'll just say far.
Yeah, 15,000 globular clusters. It's 55 million light years away,
Yep.
right? So much more further away than the last one we were looking at. It's also really wide, right? So it looks maybe a little bit smaller because it's just that sphere, but it's actually 132,000 light years across this galaxy. Absolutely insanely huge, right? And that's to give you some reference. The Milky Way is about 87,000 light years across. So, we're getting close to double the width.
Yeah. So that means for light to travel from one side of this galaxy to the other would take well over 100,000 years.
Yeah, just kind of incredible numbers here, and M87 in particular, which is like a super giant.
And the light that we're getting in our camera, in our telescope, this very second, with these images that you're seeing live from the Doane Observatory at the Adler Planetarium, left this galaxy 55 million years ago. Now that really is crazy. Just after the demise of the dinosaurs. So no, we did not have dinosaurs on planet Earth when the light left it, but it was still not too long after the demise of the dinosaurs.
So one interesting feature here is, right, not just the spherical shape of it, right, and all of these fun facts that we know about it, but you can also see just to the right of the center of the galaxy, this little line that's kind of extending out. I think Michelle's gonna point it out for us. So we can see this little line here, right? And this is actually a part of the galaxy. It is a plasma jet of essentially a bunch of electrons that are being shot out by the black hole at the middle of this galaxy. And it is extending, all the way out past the reaches of the galaxy. So we can see a little bit of it here. If we switch over to this image, this is an image that we took of the galaxy, and you can see it a little bit more in detail from here in the Doane. Yep. If you go to the next slide, we do have an image from the Hubble Space Telescope that really, really shows off that incredible plasma jet. And I was looking up why it looks blue, and it's actually due to like a specific kind of radiation happening to the electrons because of the spiral movement that they're taking as they're exiting the galaxy, which is so interesting.
So, but think of, the fact that we'll go back to our picture, see the jet, see the Hubble picture, see the jet,
right? So
see the jet.
We'll be pleased that we can see, especially just in those few seconds of exposure here.
The live view, sure.
Yeah, and then switch back to live view. There it is. You can totally see the jet. Yeah.
Yeah.
So one thing with this jet that I mentioned is that, right, this is being shot out by the black hole at the center of this galaxy, right? And there's something that's also particularly special about this black hole. If we go back here, again, thank you, NASA, for providing so much additional content for us here. If you go to the next slide, we can see what is actually the very first image ever taken. Oh, you know what? I thought this was a NASA one, but maybe it's not actually a NASA.
No, this is.
I thought this one was.
No, this is the Event Horizon Telescope. Took this image. So basically, a bunch of radio telescopes scattered around the Earth, all pointed at this object in the middle of the M87 galaxy, and took data for, I believe, several days. And they combined all the data together, and this is the best best iteration of the data that they got. So this is an area right around the black hole in the center of the galaxy. You're not looking at the black hole itself. Black holes
there's nothing to see, right?
Black, right. They do not give off light themselves. What you're seeing is the light from the material spiraling around the black hole. And so we've got it brighter in the area that's closer to us and a little bit dimmer from the stuff that's going away from us. I believe this one rotates clockwise.
Oh, there is another picture that was released of this where they had, I think, used like some AI to refine it a little bit, but I wanted to bring this one out because it was the very first black hole ever imaged. And I'm glad you brought up the rotation, because I actually looked up, some interesting numbers about this, right? To put some of these things into perspective. The gas that is rotating around the outside of the black hole is rotating at speeds of over 2 million miles an hour and is over 2 trillion miles wide. That cloud of gas that's around the outside of it.
Crazy.
Incredible. The mass that's inside this black hole that was imaged here is billions of times greater than our sun. Absolutely remarkable that we are able to, see this these days.
Cool.
Yeah.
Were there any other galaxies you would like me to attempt to dial up? Because
So what do you think? After this point, my idea was kind of we could look at whatever we wanted to. We could always try the whirlpool since we have some experience with it before.
Yeah.
I'd say we end it with one more galaxy, one more live view through the telescope. It's always fun, right? So
if our audience is
while Michelle is switching over, I wanted to talk about one other like really fun opportunity that you can have at home to connect back to galaxies. So this is a citizen science project called Galaxy Zoo that is run by Zooniverse, which is a part of the planetarium here in conjunction with some other groups around the world. And this citizen science project is actually a project where you can go and classify these different images of galaxies. So if you want to be involved in a citizen science project, right, doing some really important research of your own, right, helping astronomers out.
right.
Sorry, moving the roof. Oh, at least it was a short move, right? Oh, okay. Apologies for the loud roof noise. But yeah, Galaxy Zoo is a really cool project where you can be directly involved in like very active, up-to-date current galaxy research. So I would really encourage folks to go and check that out. All right, so I want to switch it over to our live view through the telescope. So the last spiral galaxy that we looked at, M101, is a little bit dimmer. We were pointing at it because of the supernova that's in it today. But this one has a much more, this one has much more clearly defined spiral arms. So this was actually our original first target as a spiral galaxy for today. So this one is called the Whirlpool Galaxy.
Yep.
It's M51. So Messier 51, going right back to the old Messier catalog.
Yep. The 51st fuzzy thing that Charles Messier cataloged. By the way, he was looking for comets. And because you could, if you discovered a comet, it was named after you. You could go on the lecture circuit. You could make a lot of money, or at least you could make money of some sort. And then, but he kept coming across all these fuzzy things. And he's like, but these aren't comets. I'll just catalog the fuzzy things that I find so that I know where they are. And so I can avoid
Right.
those.
So he didn't even necessarily really know what he was looking at.
No.
Right. But this catalog has become a really important like guide point for a lot of amateur astronomers, but even professional astronomy, because these are brighter objects that we can get really good views of here on Earth. It has really been a huge guide for so many people, even though it was kind of his like avoid list, which is so funny.
It includes objects that we call nebulae. A nebula is just it's a Latin word. It means cloud, and it just meant fuzzy thing. And so
save that for our nebula show.
Yeah, exactly. Well, many things on the list were called nebula, including galaxies.
And Andromeda being one of them, right?
One of the biggest,
closest galaxies.
Yeah, they didn't know that these objects were far, far away. They didn't know that they were separate from our Milky Way. So all of the fuzzy things here were called nebula. But there are some star clusters and some other stuff on the list as well. This looks so good.
Yeah, so you can really clearly see, I mean, if you want to point out some of the features that we're looking at here to help, but you can really clearly see these spiral arms, right? So that's the center. You can see that arm coming out.
I'm gonna change the exposure again.
Okay. Another thing I'm curious about is what's this kind of bright fuzzy point? Oh, well. Yeah, well, let's wait until the exposure finishes.
So so you probably saw there's a kind of a fuzzy thing that was near the bottom of the picture. That is a separate smaller galaxy. I believe it's in the background. And so it's not directly interacting with M51, meaning it's not a part of M51, but they kind of gravitationally affect each other. So yeah, it's nearby, kind of nearby. at least in the same view, in the same direction.
You're right. Yes, they certainly look close by. So
Exactly.
we're actually getting this is a little bit of a 2-for-1 deal, huh? Yeah.
Exactly. So we're
Our exposure is just about 10 seconds away from finishing up.
Yep.
And we'll be able to see some of those spiral arms in better detail. I'm glad that we could point at this because you can definitely make this one out a lot better than M101 that we were looking at earlier.
Yeah, exactly.
But of course, the supernova was really the star of the show.
Oh my God, star.
So there you go. Right. Oh yeah. Well, RIP to that stuff.
Yeah, there we go.
So here you can really see those spiral arms a lot better. And yes, that bright fuzzy point down at the bottom is that secondary background galaxy that we are seeing there. So that's so exciting. We got 3 galaxies knocked out. We gave you all tips for observing, our closest galaxy, the galaxy that we live in, the Milky Way, from a dark site that would be near you, right? We talked about Galaxy Zoo, another way that you can interact with galaxies today. I think that's a pretty good lineup of stuff for our show today.
I'm just in awe of the telescope and the camera and the fact that we got to show you this. And
it's just always awesome,
and
right?
It was clear. And if you get a chance to visit the Adler Planetarium, which we hope you do, we are open 363 days a year. But on Wednesday evenings, we are open from 4 to 10 p.m. And if it is clear out, we've got this observatory, this facility open after sunset. So you can keep an eye on our social media feeds. We're at Adler Planet on Twitter and Instagram, I believe. But anyway, look for Adler Planetarium. I know it's Adler Planetarium on Facebook, but look for Adler's social media feeds and subscribe, and you can see when we're going to be open, because we make the decision a day or two in advance based on
absolutely, yeah. And of course, also see when we're doing our next Sky Observers Hangout. We've got a few coming up throughout the rest of the year. So hopefully you will join us for those. One thing that I wanted to leave everyone with is, we've looked at a few galaxies today, but I wanted to remind everyone just how many there really are out here. This is I actually think when I first started working here, one of the questions that was asked on the staff survey was about what's something that really, what's like your favorite space fact? And my favorite space fact is the Hubble Deep Field here. Not really a space fact, more of a space picture, right? But there's a lot of facts you can pull from it. So such a wonderful story of them deciding to point the telescope at the emptiest spot in the sky that they could find, right? Something that was void of as many stars as possible, especially bright ones, and just see what happened, right? And they came back to these images, and it really completely changed our view of the universe, right? This is just in 1995, and we're seeing that there are so many more galaxies out there than we realized, right? This is a tiny region of the sky, like a grain of sand, right? Containing thousands of galaxies.
And in 1995 is when I started at the Adler Planetarium. So I've gotten to see the evolution of Hubble and the abilities of it to be able to take pictures. And now we see JWST and its ability to take amazing pictures
like this one, Webb's first deep field. Yes.
And one thing that they are doing with JWST is pointing at some of the same objects that Hubble was able to point at, so we can get even more information. But I think we should leave people with one quick live view. If you could
absolutely back. Yeah, we'll switch back to one last live view through the telescope here of the beautiful oh gosh, M31. Got my numbers. M51. God, the numbers, they're so tough. It's so tough. Andromeda's M31. Oh my gosh.
Here you go.
Messier, he really screwed it over.
I'm gonna go move that arrow out of the way so you can get that.
There you go. Well, our final parting words here is thanks so much for joining us today. Thank you for supporting our programming. We love sharing this time with you. You saw how giddy we were every time we had a new image up from the telescope. Thank you, Jennifer, for helping us out in the chat today. She'll be posting a link to a feedback survey where you can give us recommendations on how we can improve the show, maybe even show topics that you would be interested in seeing in the future. Even if you filled it out before, we love hearing updated stuff as we change things and have these new different topics that we're focusing on. So it'll help improve our shows for the future. So
exactly.
Thank you all so much for coming. Any parting words from you for today, Michelle?
Go outside, look up, everybody.
That is always a really good one. So thank you all so much. That is all for us tonight. And we will see you all next time.
Thank you, everybody. Good night.